All right, let's talk about algebraic formula. And I know what you're thinking, but forget all that dry, boring exam stuff for a second. Instead, I want you to think of these formula as a kind of secret code, a seriously powerful toolkit that lets us solve some amazing real-world puzzles. So let's jump in and crack this thing open. So here's the game plan. First, we're going to see how these formula actually connect to the real world. Then we'll start building up our skills, starting with the golden rule of substitution and then leveling up to the art of rearranging. We'll put those skills to the test with an ultimate challenge and then use them to solve a real-life engineer's puzzle. And to wrap it all up, we'll make sure you know how to spot the most common traps. Let's do this. First up, let's talk about how these formulas are actually a bridge to the real world. Okay, so let me start by asking you a question. How would you build a clock that ticks perfectly, once every single second? And no, this isn't some made-up problem from a math book. This is a real, genuine challenge that engineers have to figure out. You know, the answer? It's kind of locked away inside a formula, but you can't just crack it by guessing or throwing random numbers at it and hoping for the best. Nope, you've got to have the skills to actually rewrite and, well, manipulate the formula itself. And that's exactly what we're going to learn how to do. Okay, time to build up that toolkit. And the first tool we're going to grab, substitution. Think of this as the easy win, right? It's the one that gets our confidence up before we dive into the really tricky stuff. So what is it? It's pretty simple, actually. Substitution just means you're swapping out the letters in a formula for actual numbers to figure something out. Sounds easy enough, right? And it is, but there's this one little detail that trips up so many people: negative numbers. And this right here, this is why we have what I call the golden rule of substitution. You have to use brackets for negative numbers. I mean, just look at the difference. On the left, with the brackets, we get the correct answer, 21. On the right, without them, the calculator gets totally confused and spits out negative 16, a completely different answer from such a tiny mistake. So please, remember this. When you're substituting negatives, brackets are your absolute best friend. All right, so we've got substitution locked in. Now for the more creative part. The really fun stuff, rearranging, or as I like to call it, unwrapping the subject. The whole point here is super simple. We just want to get one letter, our subject, all on its own on one side of the equals sign. So it ends up looking like x equals something. And the way we do that is by working backwards, using inverse operations to undo everything that's happening to that variable. And these are the tools we're going to use to do it. To unwrap our variable, we essentially go in the reverse order of how you'd normally calculate things. You might know it as reverse BIDMAS. So we'll undo any addition and subtraction first, then the multiplication and division, and finally any powers or roots. As you can see, for every operation, there's an opposite, an inverse. These are the tools for the job. Let's put this into practice with a classic problem. We want to make R the subject here. So, thinking about that reverse BIDMAS thing, what's happening to R? Well, it's being squared, and then it's all being multiplied by 4 pi. So to undo all that, we go backwards. The last thing was the multiplication, so that's the first thing we undo. We'll just divide both sides by 4 pi. And just like that, R squared is almost free. There's just one last layer to unwrap, that little square. So what's the opposite of squaring something? Taking the square root, of course. We do that to both sides and bam, there you have it. R is all by itself. We've successfully unwrapped it. Okay, you ready? It's time for the boss level, the ultimate algebra challenge. What on earth do you do when the letter you're trying to isolate shows up twice in the same formula? Okay, don't panic. There's a secret combo move for this, a 3-step attack that works every single time. It's collect, factorize, and divide. First, you get all the terms with your subject onto one side. Then, you use this clever move called factorizing to pull the subject out. And finally, you just divide to get it completely on its own. Come on, let's see it in action. So here's the kind of problem we're facing. To make x the subject, we first need to get it out of that fraction. It's trapped. The easiest way to bust it out is to multiply both sides by what's on the bottom, that x minus 2, and then just expand out the bracket. Now it's time for step 1 of our combo move, collect. Our goal is simple. Get everything with an x on the left side and everything else over to the right. So we just shuffle things around a bit, and now look at that. All the x terms are huddled together. And now for the magic trick, step 2, factorize. Honestly, this is the most important step. We started with two different x's floating around, right? Well, by pulling x out front as a common factor, we've basically trapped them together. We now have just a single x to worry about in the entire equation, which is exactly what we need. And the final step? It's the easy part. X is just being multiplied by that whole bracket, so we just do the opposite. We divide both sides by that bracket. And that's it. We've got our answer. X is now the subject. Boss level complete. So we've built our toolkit. We've taken down the boss. Now what? Well, now we get to see what this is all really for. Let's head back to that puzzle from the beginning, the engineer's clock. You remember this formula, right? It tells you how long it takes for a pendulum to swing back and forth. Our engineer wants that time, t, to be exactly 1 second. But there's a problem. The formula is set up to find t, but what the engineer needs to find is the length, L. So what does our clever engineer do? They use the exact skills we've just been practicing. They rearrange the whole formula to make L the subject. And now they have a new, much more powerful tool. They can just plug in t equals 1, do a quick calculation, and find the exact length of pendulum they need to build. That is why rearranging matters. Before we wrap this up, I want to do a quick lightning round of the most common mistakes people make. If you can avoid these two traps, you're going to be in great shape for any exam. Okay, two big ones to watch out for. First is what I call the square root trap. People try to square the individual bits and pieces. You can't do that. You have to get the entire square root part by itself first, and then you can square both sides. The other big one, people just forget to factorize. If you get to the end and your subject is still on both sides of the equation, you're not done yet. You've missed the crucial step. Remember to collect those terms and factorize. So, here's your final checklist to take away. 1. Brackets for negatives, always. 2. Rearrange using inverse operations, that's reverse BIDMAS. 3. Get squares and roots by themselves before you deal with them. 4. If the subject shows up twice, use our collect, factorize, divide combo. And 5. If you have a minute to spare, plug in some easy numbers to check your work. It's an absolute lifesaver. And that's pretty much it. But you know, this isn't really an ending. It's a beginning. Because you didn't just learn some random algebra topic for a test, you've just added some seriously powerful tools to your problem-solving belt. So I guess the real question is, what problem are you going to solve next?
Thank you so much for watching! And for more helpful videos, math and science videos, don't forget to like this video and subscribe to our channel. See you soon!